Hi there. Welcome to your lesson on the product and quotient rules for derivatives. Let's take some notes. We're going to do a lot of examples together here. And let's begin with a little investigation. Let's find the derivative of this one. Well, by the power rule, we know the derivative is this. And now those two are like terms we can combine and simplify to this. So there's our derivative. However, let's try something different. What if we simplified it first and then found the derivative? As we can see, these have the same exponent here, so we can simplify them by combining them first before taking the derivative. So combine them to get 9x squared, and then take the derivative by the power rule. And it looks like we end up in the same place, which is good, because we followed some sound algebra in both cases and got to the same place. So they match. That's a good thing. Let's look at a case where maybe that won't happen. So here we are. We have this one. A little bit different than what we had. Let's find the derivative by the power rule. So find the power by power rule, find the derivative of each part and then combine. Okay, so by power rule we have this and this, and then these we can see there's multiplication, so we're going to multiply it to get this. So our derivative is 80x squared. Now let's try it by simplifying like we did before. Let's simplify it before taking the derivative. So if we have multiplication here, this simplifies into 20x to the fourth. And now find the derivative of that. 80x cubed. Notice the derivatives are different. So which one do you think is correct? We did this before when we looked at the chain rule. Compare the two. Which one has maybe a flaw in the process? Which one are you certain about the process and which one has a flaw? Okay, I hope you noticed that the second one, there's no flaw. We know we can multiply those things and get that, and we know the power rule will bring us here. But here we have to kind of make the assumption that we can take the power rule in each part, but maybe that's not right. And that's true. That is not right. There's no match here, and it brings us to something called the product rule. The product rule is applied when we have a function that is the multiplication or product of two other functions. So here's a function being multiplied, just like we have here, two functions being multiplied. The product rule works like this. We'll look at what the rule is on the next slide, and we'll write it out, but for now I'll show you how it works. So how you begin is to find the derivative of something where there's a product of two functions, is you do first function times derivative of the second plus second function times derivative of the first. Okay, these can simplify. This becomes 40x cubed. This multiplied becomes 40x cubed. Add those together, 80x cubed. It matches what we had here. So your question might be, well, why are we applying this thing called the product rule here when I could have just simplified? And that's absolutely true. If you can simplify and find the derivative, do that. But sometimes these two functions will be complicated enough that you cannot simplify these simply by multiplying. Therefore, you will use this rule. So let's outline what this product rule is. It looks like this. So when you have two functions multiplied, the derivative will look like this. Okay, the derivative will be first function times derivative of the second plus second function times derivative of the first. Okay, now let's do another little investigation. Now we're going to look at quotients. What happens when we have functions being divided? So again, let's find a derivative of this one. And the derivative here can be found by taking power rule on top and power rule on bottom. So please do that. Okay, power rule on top gives us this, 80x cubed. Power rule on the bottom gives us 20x. This can be simplified. 80 divided by 20 is 4, and x cubed divided by x is x squared. So here's our derivative if we applied power rule on top and bottom. Now let's do the situation where we simplified first. So let's simplify this fraction first and then find the derivative. Okay, by simplification, 20 by 10 is 2, x to the fourth divided by x squared is this. Now find the derivative, 4x. Again, we're close, but different. So the derivatives do not match. So again, I'll ask you the question, which of these approaches do you know for certain there was no mistake made along the way? Okay, again, I hope you said the right side here, because we know we can simplify like this, and we know the power rule works like this. Over here, again, we began with the assumption that it's okay to take the derivative on the top and the bottom, by power rule, and then simplify. And that's a wrong assumption. So it brings us to the quotient rule. It's how we deal with functions when we have a function on top and bottom, and what is the derivative. Again, we'll see the full rule on the next slide. Right now, let me show you how it works with the example we were just looking at. So the power rule works like this. You take the bottom function, let's go back, the bottom function times the derivative of the top one minus top function times the derivative of the bottom one, all divided by bottom function squared. This simplifies. Try simplifying. Multiply these, combine, simplify. Okay, these become 800x fifth minus 400x to the fifth. Subtract those. We have this. Simplify that, and we are right back to here. So we can see the quotient rule produces what we know was done correctly here. And the quotient rule, again, you're thinking, wow, this is way more complex than doing this. Again, you're right. In cases where we can simplify first, we should, because it makes life easier. But again, there will eventually be functions where the function on top and bottom are complex enough that you cannot simplify like we did here, and therefore you will need the quotient rule. Okay, so here's the quotient rule. When you have a function that is a composition of one function divided by another, here's the quotient rule. To find the derivative, bottom function times derivative of the top function minus top function times derivative of the bottom function, all divided by bottom function squared. Okay, so in our textbook, these are provided, the product rule looks like what we just saw. In the formula booklet, you'll see a different form. I want you to take a look at these and notice they're the same. Here we're using the notation where we use the prime symbol, and here we're just using the dy dx symbol. So dy dx equals, so look, first function times derivative of the second function plus second function v times derivative of the u function, the first one. So these things are the same. Pause and take a look. You'll see that they're the same. And likewise with the quotient rule, we have the same thing. So again, pause and just notice and take a look at this closely and notice that it's the same as this. All right. When shouldn't we use the product and quotient rule? Because sometimes we learn these rules and we get caught up using them, but we forget that, again, sometimes it's easier to simplify. So here's a situation we already saw, right? This is the one we saw. You could use the product rule, but it's much simpler just to simplify that like this and then go ahead and use the power rule. Okay, how about this one? Well, that's the other one we just saw. Yes, you can use the quotient rule because we have a function divided by a function, but so much easier to simplify like this first and then take the derivative from there. How about this one? You might be thinking again product rule because we have a function times another function. But in this case, simplifying is also easy. This x, root of x becomes this, and now we can just simply multiply. When you multiply those things, you get this. All right, here you add the exponents to get 5 halves. Here when you multiply, you add those exponents as well, and you get this. Now this is something that can be easily, the derivative can be found easily using power rule. Okay, here's another example. Okay, right away you see fraction, division, you're thinking quotient rule, but again, much easier to just bring that thing up here. So this part here was brought up. It was brought up, and now we have this part to the negative exponent here. And now taking derivative is easy. And last one here, let's see. Okay, this one, well, maybe you're thinking, okay, again, I have a division, so quotient, so maybe I should use quotient rule. And you can, it's fine, you can. But remember these, we can actually turn this into 3 fractions and simplify each. So you can do this divided by x squared, this divided by x squared, and this divided by x squared. If you divide each one by x squared, you get this. And this is very easy derivative to take using power rule 3 times. Very easy. All right, so the main thing is always look at the functions you have and decide, can I simplify it? Because if you can simplify it easily, it will definitely help you with the derivative. If it cannot be simplified, then definitely you are using product and quotient rule. Let's take a look at some examples. So here's that one. Is that the one we just saw? Yeah, it's very similar to what we just saw. So take a look at it first and decide, can I simplify it or do I need to use one of our rules? Okay, in this case, I took it like that, I rewrote it like this. Now simplifying this would not be easy because we have this power here. If this power was not here, we could multiply through certainly, and then it would be simplified. But here we have this. So in this case, we are locked in using the product rule. So how about you give it a try? Your first time using the product rule. Let's try it out. Follow the rule, see if you can find this derivative. Okay, now let's check your work. Alright, first function times derivative of the second, and notice the derivative of the second we have chain rule, right? We dropped the exponent here, kept the inside function the same, reduced this by 1, but then since we had a function within a function here, we had to multiply the derivative of the inside here, which is 2x. So don't forget that. Don't forget chain rule. We have chain rule going on right here. Okay, by the product rule, then we do plus, and then the second function, so here's the second function unchanged, times the derivative of the first, which is right here. So pause if you need to and take a close look and notice how it follows this. Okay, first function, derivative of the second, plus second function, derivative of the first. Now all this can be simplified, so let's take a look here. Here's simplified form of that. Notice this 2 and this 2 cancelled. X squared times x became x cubed. All this with the negative exponent went to the bottom and turned into a root. And then plus, second part, 2x, and this I wrote in root form. Okay, pause again if you need to. Let's try another one. Decide, is it easier to simplify first or use one of our rules? In this case, definitely simplifying first is a good idea. Okay, we simplify by turning into 3 fractions, divide things, this, find the derivative of that right here. Our answer can be written 2 ways. Next one. Is it easier to use one of our rules or to simplify it first? In this case, simplifying would be tough. So we're going to use the quotient rule. So let's try. For your first time using quotient rule, follow the steps here, see what you get. And now check your work. Quotient rule tells us bottom function times the derivative of the top minus top function times the derivative of the bottom one, divided by bottom thing squared. This can be simplified. Give it a try and then check your work. Okay, I did all the multiplication here. Combine some things, go a step further, and we end up with this. Sometimes students do fine with the first derivative step here, but then the algebra of simplifying is tough. So pause and take a look closely. Make sure you know how to do that. Okay, let's try another. One, again, the choice. Simplifying first or going straight to one of our derivative rules. Well, in this case, you can go either way. Let's try using our product rule first and see what happens. So try the product rule. Okay, here's what we got. First one times derivative of the second plus second one times derivative of the first. Simplify this. Okay, there's a lot of multiplication there. I get this. Some things can combine. I get this. So there's our derivative. And some students would have argued in this case it's easier to simplify first and then find a derivative. Let's compare. It's important to see that maybe both ways are equally relevant here. So here's when I'm simplifying the original. I take it like this. That means I multiplied all this by this. Okay, so I multiplied everything through in the original. This is before the derivative. Now I'm taking the derivative of each bit by the power rule. I get this. I notice I can combine these two, and therefore I get here. Same thing. We get to the same place. This one is a matter of preference. Either way got you the same place. Obviously, both ways look equally easy or not easy, so it's your choice in a case like that for sure. Okay, how about this one? Okay, definitely this one simplifying is easier. If you went to quotient rule, make this one too complex. So this one simplifies like this, bring that up like this, and then finding the derivative of that using the power rule here. Check your work carefully. Alright, how about this one? Okay, in this one we need to find the derivative and set the derivative equal to 1/4 because the slope is 1/4. So find the derivative by quotient rule, set it equal to 1/4. Okay, this one's tougher for sure. So here's our quotient rule. That simplifies into this. Check your work. Now we know we want the slope, which is derivative, equal to 1/4. So we set it equal. Notice the denominators are the same, numerators are, so denominators, set them equal, solve that quadratic, and you get that. At those two locations on this graph, the tangent line will have a slope of 1/4. Last one, try this. It's going to be tricky. Let's see if you can do it. And let's check your work. So we use definitely the quotient rule. Lots of work. Pause if you need to, check it carefully. And you need to know that this one you could have alternatively brought the denominator up like this in the beginning and used product rule instead. It was your choice. Take a close look.